histograms. The first question is, the test scores from the students in a school are summarized in the table. The test scores are summarized as 0 to 30. You can see it's from 30 to 40, 40 to 50, 50 to 70, and 70 to 100. Frequency means the number of students. It's given in the table. So when we are to draw a histogram for this information, we are going to prepare a table which comprises 4 columns. The test scores from 0 to 30, and it's from 0 to 30, and it begins with 30 again, 30 to 40. It begins with 40 again, 40 to 50, begins with 50, and till it's 70, 70 to 100. So you can see in between each of these class intervals there are no gaps. First class interval ends with 30 and the second begins with 30. So that the frequency is 15, 22, 28, 39, and the class width is the difference between the class interval. 30 minus 0, it's 30. 40 minus 30, it's 10. 50 minus 40, it's 10. 70 minus 50, it's 20. 100 minus 70, it's 30. So the third column that we prepare is the class width. And the fourth column is frequency density. How do you calculate the frequency density? Is frequency divided by the class width. So the frequency is 15 divided by 30. The frequency density is 0.5. So the frequency 22 divided by 10. Frequency density is 2.2. Frequency 28 divided by 10, the class width. Then the frequency density is 2.8. Frequency is 30 divided by the class width. The frequency density is 1.5. Frequency is 9 divided by 30. Frequency density is 0.3. So when we are to draw a histogram, the first thing is we have to prepare the column class width and the frequency density. So this is the table. We are going to use the information of this table to draw the histogram. When you draw the histogram, your x-axis is the class intervals from 0 to 100. So you're going to take the scale as 0, 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. That is the x-axis, and your y-axis is always the frequency density. Y-axis is the frequency density. X-axis is the test scores, which is the class intervals over here. So you're going to begin with 0 to 30. We are going to draw the bars from 0 to 30, which has a height of 0.5. So we are going to draw the bar from 0 to 30 with a height of 0.5. Nextly, we are going to draw it from 30 to 40. That is 30 to 40 with a height of 2.2. Thirdly, we are going to draw it from 40 to 50 with a height of 2.8. Nextly, it's 50 to 70 with a height of 1.5. And finally, 70 to 100 with a height of 0.3. So let me say again, what's important here is you can see the class intervals are joined between one another. So you can see it ends with 30, it begins with 30. It ends with 40, it begins with 40. So that in between these bars, there are no gaps in a histogram. So this is the histogram for this table. The next question is, The waiting times, hours, for 40 patients at an accident and emergency department in one evening is shown below. So you can see the table. The table carries the waiting time in hours. 0 to 0.5 hours, you have 8 patients. 0.5 to 1 hour, you have 10 patients. 1 to 1.5 hours, there are 7 patients. 1.5 to 3, it's 9 patients. 3 to 5, 6 patients. So that we are going to take this information into the table of 4 columns with class width and frequency density. I explained you in the previous sum as well how to find the class width. So the class width is the difference between the class interval. 0.5 minus 0 is 0.5. 1 minus 0.5 is 0.5. 1.5 minus 1 is 0.5. 3 minus 1.5 is 1.5. 5 minus 3 is 2. So we have the class width, that is this column, and we are going to work out the frequency density. So when we are working out the frequency density, we are going to divide the frequency by the class width. So frequency is 8 divided by 0.5, which is 16. Frequency is 10 divided by 0.5, which is 20. Likewise, you can prepare the table. So this information we are going to draw it into a histogram. So the y-axis is the frequency density, x-axis is the waiting time in hours. So the frequency density moves till 20, 0 to 20, and the x-axis from 0 to 5, and the first bar is 0 to 0.5, which has a height of 16. So we are going to draw the bars for waiting time, which is the class intervals, and the frequency density. Next one, 0.5 to 1, it is 20. 1 to 1.5, it is 14. 1.5 to 3, it is 6. Then 3 to 5, it is 3. So this is how you can show the information to the histogram. And you can clearly see again that it begins with 0, move to 0.5. And the next bar is, it begins with 0.5 and it joins with 1. So you can clearly see there are no gaps in between these class intervals. Therefore, you have no gaps in between any of these bars. All the bars are connected to one another. Look at this question. As part of a data collection exercise, members of a certain school year group were asked how long they spent on their mathematics homework during one particular week. The times are given to nearest 0.1 hour. The results are displayed in the following table. So the table shows the first time interval 0.1 to 0.5, where the next time interval begins with 0.6 to 1. 1.1 to 2, and there's a gap. 2.1 to 3, there is a gap. 3.1 to 4.5, and the frequencies are given. So we have to prepare the table before we draw the histogram, because they have asked us to illustrate the information to the histogram. Now, when we are to draw the histogram, we have to complete this table. First column is the time spent, that is from 0.1 hours to 0.5. And nextly, it's 0.6 to 1. Thirdly, 1.1 hours to 2.0. Now you can see in all of these class intervals, there is a gap between 0.5 and 0.6. There is also a gap between 1 and 1.1. There is a gap between 2 and 2.1. And there is also a gap between 3 and 3.1. So the time is a continuous variable. And we are going to draw this information into a histogram. In a histogram, there are no gaps between the bars. If you just draw this from 0.1 to 0.6, there will be a gap between 0.5 and 0.6 with the immediate next bar. So when you are drawing a histogram, there are no gaps between the bars. What you do, you're going to calculate the lower class boundaries and the upper class boundaries of each class interval so that there will no be gaps in between each bar. How do you calculate the lower class boundary? From 0.1, I will subtract 0.05. So my answer is then 0.05. Upper class boundary, for 0.5, for this 0.5, I will add this 0.05. Now the upper class boundary is 0.55. The upper class boundary of the previous class interval becomes the lower class boundary of the next class interval. So now what happens? From 0.6, when you subtract 0.05, you will get 0.55. It's same as the upper class boundary of the previous class interval. And thereafter, how do you find the upper class boundary of the relevant class interval? For 1.0, you add 0.05. Now it becomes 1.05. 1.05, the upper class boundary, becomes the lower class boundary of the next class interval, so that 1.05 is the lower class boundary, and when you add 0.05 to 2.0, it becomes 2.05. Now you can see for each class interval, for the lower class boundary and for the upper class boundary, I adjust 0.05 plus and minus. So we can prepare the lower class boundary and the upper class boundary of each class interval likewise. Thereafter, when you subtract the lower class boundary from the upper class boundary, that means the difference between the 0.55 and 0.05, your class width is 0.5. When you subtract 1.05 and 0.55, when you take the difference between 1.05 and 0.55, you will get the class width as 0.5. When you subtract 2.05 and 1.05, your class width is 1. And when you subtract 2.05 and 3.05, your class width is 1. Whereas when you subtract 3.05 and 4.55, your class width is 1. So the difference between the upper class boundary and the lower class boundary, we call it as the class width. Now, this table, I am going to draw it into a histogram. When we draw the histogram, we have to draw it frequency density against the time spent, which are the class boundaries. So the x-axis going to be the class boundaries, y-axis is the frequency density. I will mark the y-axis, the frequency density from 0 to 30, as the maximum value here is 30. And the x-axis, I have to mark the class boundaries. I will start with 0.05, leads to 0.55, 1.05, to 1.55, 2.05, 2.55, 3.05, 3.55 and 4.05 along with 4.55. So the difference between each two values is 0.5. So the first bar is to be drawn for 0.05 to 0.55 with a height of 22. So this is the first bar. It's from 0.55 to 0.05 to 0.55. The height is 22. Nextly, from 1.05 to 0.55, height is 30. Next, 1.05 to 2.05. That means the third class interval. You can see I am drawing this 1.1 to 2 to the class boundaries of 1.05 to 2.05, and the frequency density is 18. So that is the third bar, and the fourth one is from 2.05. That means this particular class interval, I will draw it to the class boundaries of 2.05 to 3.05, and the frequency density is 30. And the last one is from 3.05 to 4.55, the frequency density is 21. So it has a height of 21. It has a height of 21. Alright, so each father in a random sample of fathers was asked how old he was when his first child was born. The following histogram represents the information. So this is the histogram. So we want to know the number of fathers between 25 years to 35 years. How do we do this? Look at this. Now 25 to 35. These are the values that you have to take. How do you find the number of fathers? That means, in other words, it's a frequency. You take the area of each rectangle. You take the area of each rectangle. How do you calculate the area of this rectangle? Here 25 to 30, you have a gap of 5. And the height here is 4.8. So when you multiply 4.8 by 5, you get the area of this rectangle over here. And the area of the next rectangle is, still you have a width of 5 and your height is 5.6. So 4.8 into 5 plus 5.6 into 5 gives you 52. So there are 52 fathers between 25 years to 35 years when they get their first child. Next question is, how many fathers were in the sample? So how many fathers are there in the sample? How do you calculate? You have to calculate the area of each rectangle separately. And you have to add it. So in other words, the area of the rectangle is equal to the frequency. Area of the rectangle is equal to the frequency. By adding up the area of each rectangle separately, you can find out how many fathers were in the sample. We can continue. More questions will be there in the next video in histograms too.